Hi and Assalamualaikum. Today I want to start with a new chapter, Introduction to BJT Small Signal Analysis. Transistor can be employed as an amplifying device, that is, the output sinusoidal signal is greater than the input signal, or the AC output power is greater than AC input power. For a system that has input power P-in and output power P-out, the power efficiency can be defined as P-out over P-in, and it is not greater than 1. The input DC plays the important role for the amplification to contribute its level to the AC domain, where the conversion will become like this: P-out over P-in. For the analysis and design of the DC and AC component of BJT network, we can separate the analysis of DC and AC response of the system. First, we make a complete DC analysis of a system, and then the AC response can be determined using a completely AC analysis. In this chapter, the amplification will be expressed as voltage gain, AV, and the current gain, AI. AV is equal to V out, voltage at output, over V in, voltage at input. And for the current at output divided by current at input. In the BJT AC modeling topic, you will learn about how to convert the circuit and also the BJT into AC equivalent circuit. There are two parts. The first one is the AC equivalent circuit for the model, and another one, the AC equivalent circuit for the network. The AC equivalent circuit, which is the model, will be used in AC small signal analysis. A model is the combination of the circuit element that best approximates the actual behavior of a semiconductor device under specific operating condition. It means the equivalent circuit will be substitute for the transistor in this small signal or AC analysis. The general steps to do AC analysis: first, determine AC equivalent circuit of the device BJT. Then, replace the graphical symbol of the device BJT with the obtained AC equivalent circuit. And then, apply AC circuit analysis method, either using nodal analysis, Thevenin's theorem, KVL, and KCL to determine the response of the circuit. There are two types of models I use extensively today, which are RE model and hybrid model. Let's take a look at this overall circuit. In this example, we are using the voltage divider. Okay, then determine the AC or DC supply and AC or DC component. VCC is a DC supply. The VS is the AC supplies. And then the AC component is capacitor, C1 and C2, and also C3. Okay, VE and VOut is actually the AC component too, or AC supplies. Okay. The DC supply determine only DC quiescent level of the output voltage. DC level are important for determining the proper Q point of the operation. After that, the DC level can be ignored in the AC analysis of the network. Okay, to do the AC analysis, remember that some values you have to get from the DC analysis that you have learned before in the DC biasing chapter. In that chapter, we learn how to get the Q point, how to get the currents, and also how to get the voltage level, and then use that values for the further analysis in AC. The AC equivalent of a network is obtained by, first, setting all DC sources to 0 and replacing them by a short circuit equivalent. Second, replacing all capacitors by a short circuit equivalent. Third, removing all elements bypassed by the short circuit equivalent introduced by step 1 and step 2. Fourth, redrawing the network in a more convenient and logical form. Okay, this is for the AC equivalent of a network only. And the second major step is the RE, or the hybrid equivalent circuit, will be inserted in the network to complete the AC analysis. Okay, remember there are two different AC circuit, one for the network, which is either you are using the voltage divider, fixed bias, emitter bias, common base, and many more. Okay, and for the BJT, we call it, or for the device, we are using the RE model equivalent circuit.